Hello and welcome to the class. Today's topic is forces and motions. So if we apply the force, then the object will move. So we'll discuss about the force and what are the effects of force, then what is Newton's law of motions. There are three laws of motions, then momentum and all about the force. So force is like push or pull of any object. If you push or pull any object, then we can say we applied a force on the object. So what are the effect of forces? So force can change the magnitude of the velocity of an object. It can change the direction of motion. A force can change the shape and size of the object. Like if someone hit the football or the volleyball, then it changes the direction, right? Suppose if the trolley moves along the direction if you push it, or suppose a batsman hit the ball and changes the direction. So that means pushing, pulling or hitting the object change their state of motion. So there are the different type of forces. An example is like the gravitational force, like when the two objects attract because of the gravity of their masses, then we call it a gravitational force. Two objects may attract or repel because of the charges, electrical charges, and that is known as electrical force. Two objects may touch and then there is a force. Example like if there is a book, if I kept on the table, then book is weight is, suppose mass is m, then weight is like mg, then there is a normal reaction n. So these forces are known as the contact force, or the frictional force. Also we can say frictional force. If suppose an object is moving, this is the tire and the road. If object is moving, then there is a frictional force acting. So whenever the two objects touch, then there is a contact force, and these are the examples. Now two objects may be attached by the string and they can pull each other. In this case, the tension is the force. And if the object attract or repel by the magnetic field, because of their magnetic field, then we say it a magnetic force. So today we are going to discuss about the contact forces. Okay, so now there are some types of force like balanced force and the unbalanced force in motion. So when the force acting on the object, like resultant force or acting on the object, is zero, then we call it a balanced force. So if you see this figure, like 300 Newton is acting in backward direction and 300 Newton is acting in forward direction. So if I suppose, and force is a vector quantity, so if we are going to find the resultant force, in this case like 300 minus 300, and it is equals to 0, so that's why we can say this is what balanced force. Unbalanced force is like, if you see this example, like forward force acting is 400 Newton and the backward force is 300 Newton. In this case the resultant is 100 Newton, which is not equals to 0. That means this is an example of unbalanced force. Now if object, if there is balanced force acting on the object, that means object is either remain at rest. Why? Because we know F is equals to, we'll discuss this later, ma, and if there is F is 0, that means ma is equals to 0. M cannot be, mass cannot be 0, that means acceleration is equals to 0. So either the object is at rest or have constant velocity. Why? Because the acceleration is equals to change in velocity upon time. So if v2 minus v1 is 0, that means acceleration is 0. In unbalanced force, so that means the object is accelerating. Why? Because there is a force, there is force is 100 newtons, that means we can find acceleration, right? So in this case we can say yes, object is moving or accelerating in case of unbalanced force. Now what is first law of motion? First law of motion states that if an object is in state of rest or in uniform motion, then it will continue in the same state until and unless an external force applied on it. That means object will remain at rest or in uniform motion. That means if suppose the object is moving with velocity v, and if there is no external force applying on it, that means it will continue to move with the velocity v. Or suppose this is one object. If I keep this object for few days and if there is no force I am applying, so it will not move, right? So this is the first law of motion. Now force is, we know, mass into acceleration. So if there is no resultant force, in this case f is 0, therefore acceleration is 0. This means either object will be in rest or uniform motion. SI unit of force is Newton. So how we can find 1 Newton? F is equals to mass into acceleration. SI unit of mass is kg and SI unit of acceleration is meter per second square. So that's why 1 Newton is equals to, we can write kg per meter square. Now what is inertia? So we know we can easily lift a object which is very less in mass. Like if someone asks you to lift a book, it is a book is like 100 gram, 200 gram or 500 gram, you can easily lift. But if someone say a big stone of 100 ton, and if someone want you to move it, you can do it? No. So that means mass of an object is a measure of its inertia. That means more the mass, more the inertia. That means it is what natural tendency of an object to register change in its state of motion or the rest. So inertia is like if heavier or the more massive object have larger inertia. Okay, so more the mass, more the inertia. Now why do we fall in forward direction when a bus breaks to a stop, or fall backward when it accelerates from rest? So when bus moves, we also move with the same velocity, right? And according to Newton first law of motion, if an object is in a state of motion, it will continue in a state of motion, right? But when the driver applies the brake to stop a bus, our body want to continue in the state of motion. Bus, we apply the external force on the bus, so that's why bus stopped, and we did not apply the force on the body, so that's why it will continue to move in the forward direction. That's why we fall forward. And similarly, what happened when the bus accelerate? So our bus is accelerating, that means applying the force on the bus, not on the body. That means body still want to be in the rest condition. That's why we fall backward direction. Now we'll discuss about the momentum. So momentum is the measurement, like product of mass and its velocity. That means if we denote momentum by P, then we can write P is equals to m into V. Now momentum has both direction and magnitude, and its direction is same as the velocity, so it is a vector quantity. Now SI unit, how we can find out? Mass is like kg and this is meter per second, so SI unit is kg, kilogram meter per second. Okay, so now since an application of unbalanced force bring a change in the velocity of object, it is therefore we can say force also produces a change of momentum, which is the second law of motion, we can say. So what is second law of motion? The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That means rate of change in momentum, that means P2 minus P1, change in momentum is P2 minus P1, is directly proportional to the force. So rate of change in momentum, if I write, then rate is, then we have to divide by T. So m into V minus U upon T. V minus U upon T is acceleration, that's why force is equals to mass into acceleration. Since we can write like here, is equals to sign K V minus U upon T, therefore K, this is V minus U, and sorry I missed M, so M A, K in this case is 1, so that's why force is equals to mass into acceleration. So second law of second law, what is second law? Second law states that rate of change of momentum of an object is proportional to the applied unbalanced force, or force is equals to mass into acceleration. Now if I write F is equals to ma and F is equals to v minus m into v minus u upon t, if I move this t on the other side, Ft is equals to mv minus mu. This Ft is known as impulse of a force. This is also known as the change in momentum, which is impulse of a force. So how we increase or decrease momentum? So by increasing or decreasing the velocity, because momentum depends upon the velocity. So there is an example like the fielder pulls his hand gradually or slowly with the moving ball with holding a catch, so decrease the impact or decrease the momentum so that the ball will not hurt him while catching the ball. Now moving to the third law of motion. The third law of motion states that when one object exerts a force on another object, the second object also exerts the same force in the opposite direction. That means every action there is equal and opposite reaction. Example like when a sailor jumps out of a rowing boat, as a sailor jumps forward, the force on the boat moves in backward direction. Or the recoil of the gun is also an example of this one. Now conservation of momentum. So total momentum we know is always conserved when there is no external force applied on it. So before the collision and after the collision momentum are equal, so we can write this. Now moving to the question, because there is less time, so I have to finish this question also. So mass in this question is like 20 kg and acceleration is 5. They're asking what is force. So force is equals to mass into acceleration, which is easy question like 100 Newton. Okay, now moving to the next question. A car speed up from, this is u is equals to 12 meter per second, v is 20 meter per second, in time 6.4 second, and mass is 1200 kg. So we know force is equals to mass into acceleration. Mass is already given, a we need to find out. We know v is equals to u plus at, v is 20, 12, u, a we don't know, time is 6.4. So 12 minus 20 minus 12 is 8. 8 upon 6.4 is equals to a. We can remove this. We can write like this. 8 into 8, 64. 8 into 10. So 10 upon 8 we can write also 5 upon 4. A is equals to, we can divide like this, 4 into 1 4, this 0.04 into 2 8 4, 1.25 meter per second square. So force is equals to, or we can directly add 1200 into 5 upon 4, just cancel it, 4 300, and this is like 1500 Newton is the answer. So this is how we can find force. Now next question based on the momentum. So two objects of the velocity, you can see one object is moving with the velocity 5 meter per second, another is 3 meter per second. So the object have the same mass, so both the object have the same mass. Consider this one has m, this one has also m. Object x has a velocity 5 meter and object y have velocity 3 meter to the left. X and y now collide together, like collide and stick together. That means this is the final thing, m and m, and they are moving with the velocity v. So what is the final velocity, right? So momentum, initial momentum is equals to final momentum. So m into 5, this is the initial momentum of first object. This is what, m into minus 3. Why? Because this is in opposite direction, so that's why is equals to m plus m. It is what, 2m into velocity is this. So I'm taking this velocity is like, I'm taking this velocity is positive, towards right is positive, so left is negative, right? So 5m minus 3m is equals to 2mv. 2m is equals to 2mv. M and m cancel, 2 and 2 cancel, v is equals to 1 meter. Now m is positive, sorry, v is positive, that means it is moving in the correct, like in the towards right. So 1 meter per second toward right. Okay, so this is like, I will come in the next session for more question with more question. Thank you for watching, share and subscribe.